Guys, I know it's been a long time since I've uploaded a video, so today's video is a special Christmas edition video. I know it's the Christmas season, so Merry Christmas to all of you guys. Today's video is an A-level physics question related to the concept of energy. I know many of you guys have this concept coming up for exam, so hopefully this video has helped you all in order to understand this concept much more better. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And yeah, let's start with the video. Alright, so the question is asking us is that a simple pendulum has a mass of about 650 grams and a length of about 0.8 meters. It is pulled out to an angle of about 20 degrees from the vertical. The pendulum is released. Assuming air resistance is negligible, calculate the maximum speed of the pendulum bob as it passes through the vertical position. So there are some important concepts that we have to understand before we solve this question or before we analyze this diagram. So we have to understand is that when a pendulum bob is at its maximum height, it has gravitational potential energy. So now what is gravitational potential energy? Gravitational potential energy is just the energy that an object gains when it's raised at a particular height. So what I mean by is when you raise an object, let's say to a certain height, it gains gravitational potential energy. Now as this is dropped to vertical position, all of this is going to be converted into kinetic energy. Kinetic energy is just energy of a moving object, alright? So once we know these concepts, the first thing that we're going to do is we're going to find out what's the vertical and horizontal component. So in this diagram, we're going to find out what's the horizontal component in this case. So we know the horizontal component is somewhere going to be around the adjacent side. So we know since that's going to be in the adjacent side, we know it's going to become 0.8 times cos of the angle 20 in this side. Since that's the horizontal component side, we have to find out that value. And we have drawn two straight lines near the center of the pendulum bobs, as you guys can see in the diagram. And after this, we have to check out all the units, whether they're all in the correct SI units. So in this case, we can see that mass is about 650 grams. We have to convert that into kilograms. So we know that 1 kilogram is equivalent to 1,000 grams. So what you need to do is you need to convert from grams to kilograms. So it's going to become 650 divided by 1,000 grams. That's going to give us a value of about let's say it's going to give us a value of about 0.65 kilograms. That's going to be your value in this case. Okay, so now we know the mass. We're going to write it down as mass is 0.65 kilograms. So that's a mass. We have found out the mass of the pendulum bob in terms of kilograms. Now we have to find out the change in height. So the change in height in this case is going to become 0.8, since we know that the simple pendulum has a mass of 650 grams and a length of about 0.8 meters. So we're going to do 0.8 minus 0.8 cos of 20, since we know that's the vertical component's height. So we have the height there. Now we have to know what is the gravitational potential energy, since we have to calculate the maximum speed, that is the velocity. In this case, we're technically calculating the velocity. So we know gravitational potential is energy. G.P.E, it just stands for gravitational potential energy. It has the formula mgh. So this is going to be equivalent to the mass 0.65. We know, we have found it out, times the gravitational potential energy. Actually, this G is the gravitational field strength. So don't assume it to be gravitational potential energy. All right. So since we know that G is the gravitational field strength, it's going to be about 9.81. That's the unit that we always take for gravitational field strength, times the height, the change in height, which is going to be this, 0.8 minus 0.8 cos 20. Now, one tip I would like to give you all is to use your brackets really well and when you're putting all these values in your calculator. So it's going to become times 0.8. I'm just going to use the calculator here, guys, so that I can calculate these values accurately. So it's going to give us a value of about 0.307 joules. That's going to become your gravitational potential energy in this case. So we're going to write it down, G.P.E. We're going to write it down, G.P.E. It's equivalent to 0.307 joules. Right, so that's the joules in this case. Now there's one important formula that you guys have to know, is that when an object, let's say it's falling, it's getting converted from gravitational potential energy to kinetic energy. So what I mean by that is we can equate both the gravitational potential energy can be equated with the kinetic energy formula. So we can do mgh is equivalent to half mv squared, where half mv squared is the kinetic energy's formula. Okay? So we know the value of gravitational potential energy to be about 0.307 joules. So that's understood. We have already calculated that value. So that means we can rearrange this equation in a way to make V the subject of the formula. So we have half times mass, which is 0.65. We know it from above, times the velocity, which is unknown, is equivalent to mgh. And we have found out what mgh is, and it's going to become 0.307 joules. We know that already. So now once we're going to do this, we're going to just simplify it. Half of, let's say, 0.65, that's going to become about 0.325 times v squared is equivalent to 0.307. So we're going to make v the subject of the formula. That's going to become v is equivalent to square root of 0.307 divided by 0.325. And this is going to give us a value of about I'm just going to use a calculator again, 0.325. That's going to give us a value of roughly about 0.9719 meters per second. All right, this is just another way of saying meters per second. This is just another notation form. Okay, so the velocity in this case, we're going to put it to two significant figures. So it's going to become 0.97 meters per second. I'm going to write it down here up to 2SF. Have they mentioned the significant figures? Do check in the question if they have mentioned any significant figures. They haven't mentioned here, but we can just assume that it's two significant figures. Yeah, we can assume that it's two significant figures. So we're going to leave it as 0.97 meters per second. Now this is the velocity that we have calculated. This should be usually for about 4 marks, max 4 marks, or roughly, yeah. We have used the formulas of gravitational potential energy and kinetic energy. This seems to be the end of the video. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And do comment below on what your thoughts are about this video. And I think that's it. All right. Once again, Merry Christmas to all of you guys. And yeah, I think that's it. All right. Bye, guys.